Yes. Welcome to this session. Overview of ShopTurn programming. I want to use this simple design to create ShopTurn. This is normal turning. Then I will add drilling and some slot from this side. I can also add a groove from this side. All other features to this, so that we are able to know how to do programming using ShopTurn. Okay, let's go. So this is our part. We have a total diameter of 76.2 and a total length of 104.78. So let's start this programming, this one. Okay, one by one using ShopTurn. So once you have your machine, so this is a Siemens 840D. I'm using Siemens 840D. So let's go and start programming this. So once you have this controller, you can start programming. Let me show you how to start. So you can go to program manager, then you have the local drive or the extended version, and then the NC. If I put a flash here, let me put a USB here, for example. I can put a USB here. You will see a flash scene here. So you see, this is the flash. I can send my program over the flash, or can I open this program. I can check the content of the program. So this can accept it can accept this kind of program. At the same time, it can accept ShopTurn, but we want to look at ShopTurn. So let's go to program manager. From program manager, we want to start programming using ShopTurn. So I want to use on local drive under my folder. You can get your own folder, create here. Maybe, for example, if you want to create your own folder, click on program manager, then this dot, then from there click on this new, then say directory. Change here maybe to, let's say, practice, or let me say 16. That's, or maybe let's say anything. Just put anything maybe for the client. I can say, for example, next scenes. Okay, let's just put next scenes. So this is my folder for my client. Then for this folder, I can now create new. Then here check, you have this kind of program called program guide, G code, and also ShopTurn. So on ShopTurn, you can say, let's say practice 2, for example, or let's say practice 2 or 3, 2A, for example. Then click OK. From there, it will open this window. So in this window, we call it program header. In this program header, you need to initiate your G code. I'm using G54 for work offset. Then this is the diameter. My maximum diameter is 76.2 according to the drawing, but I want to use a diameter of 90. So I know my stock is 90. I want to put a 1 millimeter for facing, and then you have my stock is minus 150. Then the amount I've holded on the is minus 120. So put here symbol, because I don't have any boring inside. I can put symbol. If I put extended, meaning I'm doing boring, I don't have anything, so I put symbol, and then I can retract by even 10 millimeters. Okay, retraction. Then you can come here to teach machine, click on teach position. It can pick the point for teach positions. Then click accept. From this one, you go to turning, stock removal, change here to face, put maybe 0.25, 100, change, select the tool from the tool list. In case you need to create a tool first, I've jumped the step because you need to know how to create tools. And then from there, you can go to face. My OD was 90, as I said, it was 90, 1 millimeter for facing, minus this, I can go to minus 5 for turning, or even minus 2.5, or let me put 0.25. Okay, then I accept. I can do a simple simulation to see if it will be doing my facing operation from the stock. It will do facing. So this is the facing, for example. It has completed the facing. So let's go to the program again. From this program, you want to start now creating the contour. So click on the contour, new contour. You can put any number, maybe first contour. Then I'm starting from diameter 44.45. It has affiliate, radius of 3.18. Ensure this arrow is pointing up. This arrow is pointing up. If you put it down, it's internal turning. So ensure you point up. This arrow points up like that. Then you accept. From there we go to horizontal. So you have a Z of minus 12.7. Accept. You can see on the graphic it's drawing. Accept. And then we go to taper. I can go to X 31.75. My Z is minus 25.4, and then this doesn't have a chamfer, as you can see. And then I can accept. From here, this is minus 25.4 because I've put a lot of minus 25.4. Accept. Then from there go to horizontal, put my Z is minus 38.1. Be keen with the values you put. Accept. Then go to another angle, taper. My X is 44.45. My Z is minus 50.8. Okay. Accept. Then go to horizontal. My Z, let me go. My Z is minus 69.85. It has a fillet or radius of 6.35. Okay. Accept. Then from there it goes to vertical. X is 63.5. Let me put that 63.5. Yes. I can put, let me put like that. Okay. Accept. Then from there let me put a radius so that you see how we put a radius. This radius going anti-clockwise are 6.35 academics. My X is on 76.2, like that. My Z can be minus 76.2, for example. Accept. Then you see it creates a sketch here. Click the dialog select. I want this one, so you click on dialog select, then accept. Then from there I go to horizontal. Z is minus 104 plus, in case I have a tool for parting, and I can put 104, or maybe put minus 110, for example, minus 110. Okay. Then from there accept. Then go to vertical to 90 for safety. Accept. So we have a sketch here. As you can see, this is now the contour we want to cut. Then from there accept. Once you accept, now come here to the same other contour, below new contour, click on new stock removal, check the tool that you have the correct tool for OD turning. Roughing, can put 0.25 depending on the material, can put minus 140 depending on the material. I'm doing here roughing, so this is roughing, this is finishing, this is roughing and finishing at the same time. So this is meaning I'm using a different tool. Then I'm doing outside diameter. My diameter here was 90 for the stock. Then I can say accept. Don't have any undercut here, I say accept. Let's look at the simulation first of all, then I'll show you how to add other features for now milling, because this is a Turn-Mill machine, Siemens 840D. So you see, this is what we cut. But remember, you see this contour is going inside. I can use a grooving tool to cut, or I can use a turning tool to cut. So I want to use a turning tool to cut. How do you cut this contour? Because remember, it has left a material here. How do we do it? Come here and edit. Go the first part for the header. Check here that all the parameters are okay. Once you okay, come to the stock removal for roughing. Ensure that you check that all parameters are okay. Now go to this stock removal for roughing. Ensure that you say there's undercut. So that it takes the material going inside the curve, so that the tool can now cut. Then click OK. If I do a simulation, you'll see the material now, the tool now enter in the material to cut, so that it doesn't leave any amount. So as you can see now, doing turning, now it has cut this undercut. Okay, so we want to add a center drill. So you come to drilling, then you say center drilling. You can pick a tool. I want to use twist drill fixed. So this is twist drill fixed. Let me check on this drill fixed. So this is the axial but fixed. Diameter, I want to use on diameter 6. I don't want to use this one, so be 6. Let me edit this one. I can add here as fixed, so that you don't confuse the tool. So okay, so this is the tool I'm going to use, diameter 6. Let me change it to diameter 6. Let me choose this tool, accept. Then this one I can put 1000. Okay, Z starting from 0. I can check here on the graphic. You can see from the graphic, and use the tip. For example, I can check on my drawing, which was not there, but I want to modify the drawing to create this feature. So I can go to -25 or -20, -22, for example. I'm using the tip, then calculate. Then from there I can also add, for example, pocket. Here I have a diameter of 38, so I can come to here, for example, milling. Then you can do a pocket mill. The end mill is axial. I want to use axial end mill. On the face, centric, I want to just put 1. The diameter here I want to put 30, for example. Let me go -10. Tool full length 10. Then calculate. If I do a simulation, you will see what happens with what we call mill turn. So this is a mill turn using ShopTurn. You can program using ShopTurn to do your milling. So let's see. Program manager, I can do 100%, but you can see how it cuts. So you see this is the tool is cutting inside. Yes, this is what it is doing. And then I can also add, for example, in this program on milling, there is different kind of, you can do like contour milling, have a multi-edge, pocket, thread milling, engraving, all of them. So we have done, in case we do a simulation, we have done this part. We have done turning. At the same time, we have done milling using ShopTurn. Let me minimize. You can see how it cuts. Maybe, for example, you can rotate this one. You see this now external turning, and then it will come to do center drilling. From there, it goes to do pocket using circular pocket. Yes, I can even reduce this one. For example, let me put it 25. Okay, and then at the same time I can put center drill using what you call deep hole drilling. I want to use a twist drill of 6, fixed one. Okay, no, this one should not be fixed. This one should be axial now. Twist drill of 6. Let me use a twist drill of 8.5. Let me check a tool here. I can use this one. Not fixed. Don't want to use fixed. That is I can create a new tool here. Let me create a new tool. For example, go to offset, then this one, new tool, drill. I want to use a twist drill, but remember, this twist drill, I want to make it 6, but I want to make it active. So I want to make it axial but active, or live. Let me put live, L as live, so that I believe the tool is live. I can put here diameter is 6. Okay, this is diameter 6 for this tool. Now this is this one, all of this. So because you can see the tool now, I can go to program, then I continue to pick my tool as live tool. Okay, chip breaking, I want to use go -20, -23. Okay, using let me use the tip, then accept. From here come to positions. I want to use a position. How many? This is the diameter. and I want to use diameter, I can put diameter 35. Let me go to Z, that is Z0. So this will be face, Z0 starting from 0. Angle I want to put to angle 45. Here I want to put R 35 stroke 2. Then how many I want to put them, like 5 or 6. Let me put 6. Okay, then accept. You can do a simple simulation and see how what you call ShopTurn is so powerful for Siemens 828 and 840D. You can see how it does turning and then milling, because these are turn mill. We have what you call turning and milling. It is combined, so you can see how it will be doing center drilling. We have a face pocket on face, then have this drilling. You can see very perfect. I can also add a different entity. For example, on this one I can say I want to do milling, but what you call multi-edge, and then I want to use axial and mid axial 8 on the face, that is face. The diameter, for example, this is diameter 44. Let me put 44.45 where I want to place. I want to go, let's say, minus 12.7. Number of sides I want to put like 8. The length of this can put even to be, let me say, 20. This one goes minus 12.7 from 0. Here I can put, let's say, like 18. You see, it goes inside. Then I want to put 12.7. The tool can go direct 12.7. So this is what I have. So on this diameter I want to cut this length, and then the angle can put to angle, let's say 45 for example. I'll show you, then accept. Then you do simulation. You will see how it will be doing milling. We call it Turn-Mill program, which I'm using ShopTurn to do programming. So you can see how it does the program. Very simple. It's called ShopTurn. So it will do cellar drilling, it do pocketing on the face C. It does drilling. Then from there it will do what you call, you see, very simple operations. I can come and add a slot on here. For example, milling, then do a slot. This slot I want to show the graphical. For example, I can put a slot radial, to do should be radial position. I want to do pattern on this one, length can be this 60. Let me show you. Let me put 40. Then a depth of minus 3 is okay, 5, okay. Then I can accept. From there I can come to positions, put these positions but change to per C. Then from there the diameter here is supposed to be, let me put on which diameter I want to put on the largest diameter. So let me change the diameter here to be I want to put on diameter 76.2. so 76.2 here, sorry, put here 76.2. Then the distance is 76.2, so that is 104. Let me calculate. 104.78 minus 76. 104.78 minus 76.2, you get 28.58. divided by 2, you get this. So plus 76.2, I will get something like 90. So let me put here minus 90.48. Here I want to put them like 3 or 4. Let me put them 3, 4 so many. As you can see on the graphical, yes, you can see on the graphical it is per C. Then okay, let's do a simulation. You see what will happen when you do a simulation. Yes, when you do a simulation, what will happen? Okay, you see now turning. I'm not done finishing, and then from there it will come to do a standard drill. then pocket, that is what the face pocket, and then drilling, deep hole drilling, then from there multi-edge, then from there it adds a slot. You see, this is a slot, it adds a slot. The slot, you can here say override 100% or plus override, for example. You see what it will be doing. So it add 3 of them depending on the size of the slot. So this I'm putting slot on the pass C or pass Y. You can call it pass Y. You have pass Y and pass surface Y and sheet Y. Sheet Y is like you're doing facing on the Y on the Y axis, but this I'm doing milling, but across or along on the surface of Y. So this is a turn-mill, so it has X, Y, and Z axis, but the main axis is X and Z. So Y is the auxiliary axis, as you can see how it is doing it. So this one now using Y axis at these cuts. Okay, so once it finishes, I want to show you how now to add a groove from this side. You can add a groove on this side. So this is almost done. I can even add 100% or override as many times you can see. So it will be doing all these operations. Remember, this is what we call now turn-mill. You see how powerful this is. I want to put a groove here, a groove at the center. So in this program, let me check the dimensions. We have 25.4 minus 38.1, we get like 12.7. So come here to turning. I want to add groove, OD groove 200. Then here diameter is on diameter 31.75, where we are adding Z is going to, let's say, that is 12.7 plus 25. So let me add 25.4 plus 6.35, and then I change here to negative because I want to go inside negative. You can see on the graphic area. So this is where the tool is, and then I want to add 5 to be at the center, for example. This I want to go to absolute diameter. This diameter can be 25, is okay. Chamfer of this, I want to put 1. Then okay, let's do a simulation. You see how to be doing the groove. So that is the beauty of Siemens 840 or Siemens 820D when you're doing ShopTurn. So it's good each time you're programming to do your simulation to understand how the tool will be cutting each of the operations. So this is how operations are done. You see, very simple in ShopTurn. So this is what you can do. If your machine is able to cut this, you can do ShopTurn. As you can see what it's doing. As you can see what it's doing. Okay. Can override this one. Let me overwrite it to go faster. Can put it to 100. Maximum override to 100. This for simulation purposes. You see, and then I'll put a groove somewhere here. You'll see what it will be doing for the groove. So this, then you have the groove. You see the groove. You see the groove. So I can come here and edit my groove parameters. If I didn't want to have a sharp groove, then I have to change this. You see now, I will come here, put a different groove, for example, groove, then pick the second one. So the second one, then I put a chamfer. I want to put a groove of 1 on diameter at 1.75. I want to say Z is minus 28, for example. It goes to 25, blah blah, and I have 5 of it, for example. 5 of it. Then from here I can go to 0 and put 0 angle. You see the graphic how it shows you. So in case it's so, I can add to minus 30. So that's the beauty with this. I can add to minus 32, for example. This can add to minus 35. You see how it gives you minus 34. Yes, this is the beauty with this software. I will remove the other one because I don't want to use that one. I can put a 1. I don't want to put chamfer. Let me put 0. Even this R3 can put 0. Let me put 0, 0, like that. So the first one, I want to put a chamfer of 1.5. And then the last one, a chamfer of 1.5. You can see, or a chamfer of 1 is okay, 1.5 is too big. Okay, you see this is what it has done. Then I click OK. From there I can remove that one. Then let's do a simulation. You'll see how it does the groove. So this is the beauty with it. Siemens 840D. You're able to change the parameters as you wish, so that it suits the design. So we have put some parameters which was not in the design to simplify the programming. You can see now doing the pocket on the face, doing the drilling. You see, these are the drilling. Doing this cycle, 100% override, 100%. You can see. We want to see the groove here, how it does the groove. That's the beauty with the this is the beauty with the Siemens 828 or 840D. So this is a turn-mill. As you can see, it's doing turning at the same time it's doing milling. And then I can transfer this program to the flash. Then from there I can now transfer it to the machine. You see. Let's see what it's doing. This last slot, I had put 3 slots, but it's going on the pass surface C, or what you call pass surface Y or sheet Y. You see. So almost put 100% override. Now the groove, you see. You can see the groove here. You can see the groove. This is the groove. You can see the groove, and you can see our drill. So I want to increase the depth of this drill, the depth of this pocket, circular pocket. That's okay. There's this twist drill, deep hole. I want to increase this. It goes to minus 25.4. Okay. Then I can do a simulation to see the changes in the drill. So this is what you call the you see, this red one is the angle, because the C is now changing, so it must follow this angle as changes. Now you can see. Yes, can do override, maximum override, because I wanted to see the hole. If it has cut the way I want. Yes, you can see now. You can see how it is. This is what you call we have done these features. You can see these features. So I can add the length for this multi-edge. I want to go to minus 15. Let's go to 15. Okay, do a simulation so that it can cut what I want. Yes, I want to see maximum override. Okay, it's almost drilling. I want to see the features here. Yes, yes, see, it has cut what I wanted. There's no material left there, you see. So this is the beauty. Yes, you can see that is the beauty with the what you call ShopTurn programming. As you can see what it has done. Yes, you can see what it has done. I can also do part of. Let me show you how to do part of program on ShopTurn, but remember the tool must be correct. So come to turn, then cut off. Let me put a cutoff of 380 on this. The diameter is 76.2. We want to part off. It goes to minus 76.2. Let me check the total length where I want to part off. I'll show you. I want to part off at minus 104, sorry, 104.78, minus 104.78. Chamfer here can be even 1.5. I can put a chamfer 1.5. From there I put like at 30, the speed should be reducing, then accept. Then lastly, let me do assimilation. But remember, you need to have a proper cutting off tool because the diameter is bigger. If the cutting length of the tool is not uniform or is not good enough to plunge the material, it will affect the output. So don't just program and then you part the program on a machine without understanding the parameter or topology of your tool. It's very important to understand the topology of your tool so that you don't affect the output. Programming may be simple, but now connecting between the program and the tools is very important to ensure that you don't affect the machine, or you don't affect the tools, or you don't affect the or injure any person whatsoever during the machining. Then lastly, we do part of as we have programmed at minus 104.78. Let's see, wait. Let me put to different view, side view, so you can see now this is the final part we require us to use. You can see this is our final part. This is our final part. From this program, you're able to check other parameters. For example, I can add a pocket on this. Let me add a pocket on this. On the before the end of this, let me do milling, and then I can do a pocket. But I can change this pocket to pass surface. I want to use a circular pocket or rectangular pocket if you so wish. And then I want to change this the diameter on this. Let me change the graphic. The diameter for this pocket, I want to use the end mill of 8. I want to put 12. The X will go, let me put incremental minus 3. I don't want to go deeper. And then this one vertical, but on what diameter I want to put pattern, for example, pattern. This is diameter. Use this pattern. I want to put a pattern. Okay, let me put a pattern. Okay, and then I can come to drill, check the pattern. From this pattern, this is per surface C. The diameter is 76.2, for example. Z, I want to go to Z. Was it minus? Let me check the length that I put. I want to put 104.78 minus 76.2. That is this divided by 2. You get this one plus 76.2 and get minus 90. So let me put 90 is okay where it is. By this one, let me put 0. I want to show you something so that we'll be able to understand why it is so. Let me put this one, then do assimilation. Assimilation is possible for this circular pocket. So let me check the parameters. The tool is end mill 8, 15 here, minus 3, distance is let me put 5, goes twice, vertical, centric. The tool should be center, pass surface, okay, outside. Okay, let me check this one, graphic. I want to put 3 of it at this point, diameter 76. So also pass surface. Okay, let me check these parameters. I think it's the tool, yeah, the tool, and the mill should be not actual, should be should be radial. I want to use end mill radial, sorry, should be end mill radial, not axial, because I want to add end mill radial, yes, 8, accept, then do assimilation. Not axial, because axial on the face C, so it should be end mill radial. So let's see what it does, and then I'll show you how to maneuver with these parameters here so that it goes to the correct position for the cutting. Okay, let's see. So now it's doing slotting before it comes to groove. Slotting. We want to see how I've put angle 45. I want to show you how I can change this to a different point here. Yes, to a different point here. I'll put override to 100%. Then we put override, maximum override. Okay. Then yes, you see where it has come. You see, that is first one. Yes, where it has come. So we need to use the right parameters when you are changing this point. Yes, 3D side view. We put it to 3D. You see what it has done. Yes, so you can change these parameters as you wish. For example, here in this one, put the angle 0, but on the positions I have put 0, or I can put even 22.5/2. You'll see what will happen. And then before cutoff, this program I can do mark with this, and then say cut. Before this, I want to put mild edge slot, this one cylindrical slot. So this one here I want to put here first. It comes after that one. Then let me do assimilation. You'll see after that slot, the slot, it comes automatically put what I want. So because I want to see the changes, yes, and I've just changed the angle, so you see what happens if I change the angle. Slot, so doing the slot. You see, second one should be third one. Changing the parameters here. You see what happens if you change the angle. You see, it affects the output. It gives you a different picture. So this is how you're able to program. I can even come and change the angle again. So where to change the angle is very important. So you can change the angle from this one. For example, this is where you can change the angle. Maybe I can put to angle 30, for example. Click OK. Then from here, so it can go the correct point when it is cutting. So it is good to understand the parameters before you start programming. Yes, you call them the cutting parameters and also the dimensions for your design, because it will affect the output and how you orient the spindle. This spindle, as you see, it is oriented depending on the angle you have put when you are programming. So it's very critical when you are programming, understand the orientation of the tool. Let me see how it is going to cut the first slot. As you see, from first slot it will go to the second slot, then it goes to the third slot, then it comes back to the pocket on the surface. You can see this is the second. You go to third. Now this is the third one. Then you will see where it starts. As you can see from this. Once finished that one, you see what will happen. Because I've twisted the angle. I want to show you the effect of the angle when you are programming. How you twist it. Groove. Then it comes to part off. Yes. You see the angle I've twisted. The angle is inside. Yes. Because I put angle 30, so it will go inside the material. The angle I put 30, that's why it's going inside the material. You see, this one is inside. So this is very important. These angles are very important when you're programming. I can put it to 0. Yes. And then this angle, I can change this angle 45. I can put it like say 22.5 or 30. Let me put 30. Then you will see the difference how it behaves. Yes, how it behaves. Let's do a simulation again. So those are the effects when you are programming. You need to understand how to change the parameters in your program because they affect the output. Okay, as you can see. You see. The second one. So this is what we call milling, is turn-mill. Turn-mill. Whatever it's doing, it should be doing on 4-axis or 5-axis milling. But a machine can combine turn and milling. You see, it can combine turn and milling. Now, do you see what it's doing? Yes. So my 0 point is starting from here. So how can I shift my drawing, for example, a slot, so that I can shift it to a different point? So I can come to the program and then change those locations. Yes. As you can see what it's doing. Yes. So this is what we have cut on the program. So this angle is very important. You can twist these angles to the point you want or to the location you want. These angles are very important. You can twist the angle the way you want to be, so that you create a point where it suits what you require for easier of machining or adding other features you want when you're using what you call ShopTurn. So this is a ShopTurn programming. In case you want to learn more, you can call us. We will show you how to create a program using Siemens controllers on what you call ShopTurn. See, very simple way of programming what you call milling and turning. As you can see, what is this? What is it is doing? Yes. And then let me finish as I wind up. So this is Siemens 840 or Siemens 840D controller for turn-mill or mill turn machines, where you can program both turning and milling. We have drilling, we have turning, we have milling at the same time. So it is what we call turn-mill. The majority is turning, but we have added milling, so we call it turn-mill. As you can see what we are able to achieve on this side. So I will also show you the program. If I want to send my program to machine through using a USB, how do I do it? You see, this is what I want. So I can put in my flash, for example, flash disk. Let me put in the flash disk. You will see the flash disk is visible. So what do I do? I will click on Program Manager, and you will see the flash is in here. This is my program. I can copy together with the folder. This one, say copy, and then come to my USB. Somewhere where I want, I can say paste. For example, I can click here, then say paste. It will paste with the right programs. I can come again to local. What programs do I want? I can copy this one. I say copy. I go to my USB. I click here, and I say paste. All of this program goes to my flash. So I can take this program to my machine. As you can see, I can go to also NC. I check the program that I have. For example, if this is a program I have, I can copy this program and say mark, go down all the way, maybe for example I can copy all these programs up there and then say copy, come to USB. I can create a new folder here. There's a new directory. I can say this, for example, tests. Click OK. Then under that, these tests, I can paste my program inside the tests. So you can see I have these different folders. I can also remove this one and then say mark up to this point, then say cut, come to this test, say paste, and then so I have program in different folders. So I have this program in this end, you have this program here, so all of them have different entities. Yes, I can even cut this one, say cut, click here and then say paste, so that it has its own folder. Like example, now you see Dalkrins has a folder, Nexin has a folder on its own, test has a folder on its own for the practice. All of them, all these programs, they have been arranged in their specific categories. And able to access this program, for example, I can open here the program. This is a program you have created. And then I can do even numbering. I say now number from maybe 10 to 10, accept. It will automatically saves. If I go to Program Manager, I'm able to see all these programs. For example, if I click on Test 2, open it, you see these programs. If I go to Program Manager, I can go to another different entity. For example, exercise this. I click Open. You're able to see the program. I can edit from the USB one by one. Then I can go now take my program the machine. Though this is easier way of programming, you can use your computer to have this soft setup for numeric or operate from Siemens. Then you program and then you take the program to the machine through the USB, so that you can now cut your part as required. Thank you for your time. Thank you for following the session. It has been too long, but educative at the same time and important for ShopTurn programming. We call them ShopTurn programming. Okay, let's go back to where we were for this practice 1. Okay, thank you. Have a lovely time.